All right, we're doing the front of this homework for one night, and then we're going to do the back of this homework for the second night. But so I want you to save this number 2b for later so I can go over that, okay? So let's take a quick peek though at these ones at the top. We are starting with the quadratic formula, yay! That means you're going to need this big old formula, x equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, there it is. I sang it. I'm going to sing it every time to annoy you guys so that hopefully it gets stuck in your brain. Here we go. We got to get a, b, and c. A is the number in front, an invisible 1. B is this number in front, and C is this number at the end. A, B, and C. A, B, and C. And what do I mean by A, B, and C? That comes from standard form of the quadratic, ax squared plus bx plus c is our standard form of the quadratic. So you see that the a is the number in front of the x squared, and the b is in front of the x, and the c is at the end. In order for us to solve using the quadratic formula, this standard form needs to be equal to 0. So notice here that all of these are equal to 0 and ready to go. So when they're equal to 0, we're ready to get a, b, c and plug it in and see how we do. So A is 1, B is 9, and C is negative 6. We want to write the formula every time completely out so that we start to memorize it. Now we get ready to plug in with our open parentheses. Okay, here we go plugging in. I'm going to plug in a B of 9, plug in the next B of 9. A is 1 here and here, and C plugs in here. That's a negative 6 for C. See if you can understand how I plug those in, if those all make sense. Now we are going to simplify. Negative times 9 in the front is just negative 9. 2 times 1 in the bottom is just 2. Now let's simplify the discriminant. This part under the radical is known as the discriminant. 9 times 9 is 81. Negative 4 times 1 times negative 6 is 24. See if you can see how I came up with that. All right, so we're going to get under the radical the square root of 105. So going off to the side, let's see if we can break up this 105 at all. What goes into 105? Well, the fact that it's a 5, I hope you realize it can be divided by 5. So we'll start there and we get 21 times 5. Well, 21 can be broken down as 3 times 7 times 5. Do you see any pairs that I can take out? No, so the radical is actually already simplified. It's already done. We don't have to do anything else to this one. Every once in a while that happens. So this is it for my answer. And this answer is telling me that we have 2 real roots. And what that means is you have 2 answers. The first answer is negative 9 plus root 105 over 2. And the second answer is negative 9 minus root 105 over 2. I just want to be clear that you can see that there are 2 answers here. This one and this one if I break up the plus or minus. Okay, for real, pause this video and go try the next one on your own. Okay, let's see how you did. Did you get that A is 2, B is 8, and C is 3? x equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, I know some of you are muting me. I accept it. Get ready with your open parentheses. And let's see where you plugged things in. Did you plug in b of 8? 8. A is 2. And c is 3. And now let's simplify. Negative times 8 is just negative 8. And on the bottom, 2 times 2 is just 4. Inside, this is called the discriminant. 8 squared makes 64. Negative 4 times 2 times 3 is negative 24. 64 minus 24 is root 40. How'd you do? Off to the side, we say what times what makes 40? 4 times 10, or 2 times 2 times 2 times 5. A2 comes out. Root 10 stays under. There's my simplified radical. So this right here gets plugged in right here for the root 40. So 2 root 10. Now we ask ourselves, can we go further? Why, yes, we can. Did you do the whole thing? Did you get that 8 can be divided by 4? And 2 root 10 can be simplified with that 4 as well. So final answer is negative 2 plus or minus root 10 over 2. Because 4 goes into 4 once, 4 goes into 8 twice. 2 goes into 2 once, 2 goes into 4 2 times. And so there's my final answer. And just so we're clear, what did we just get? We got 2 real roots. Because this plus or minus means that technically we have 2 answers. All right, how'd you do on that one? Pause the video again, like for real, and try this. All right, let's see how you did. A is 3, B is negative 6, and C is negative 12. Write out the formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Get ready with the open parentheses. And let's plug in and simplify. For b, we plug in negative 6 here and here. For a, we plugged in here and here. For c, we plug in negative 12. Negative 6 is positive 6. 2 times 3 is 6. In the discriminant, underneath that radical, let's see what we get. Negative 6 squared is a positive 36. 4 times 3 is 12. 12 times 12 is 144. I'm going to split these apart already. All right, so we get 150. This is going to be 180. All right, let's go break down this 180. What times what makes 180? Like 18 times 10. 18 is 9 times 2, or 2 times 3 times 3, and 10 is 2 times 5. So I'm seeing a 2 and a 2, so a 2 can come out. I'm seeing a 3 and a 3, so a 3 can come out, and a 5 stays under. So I'm getting 6 root 5. That essentially means that 180 is 36 times 5. Test that in a calculator. Hey, that works. So this whole thing right here is going to get plugged in here for the 180. So we say 6 root 5 over 6. And those 6's cross out, leaving me with an answer of 1 plus or minus root 5. And just to be clear, that means we have 2 real roots. So how'd you do on those? Were you able to complete any or part of those on your own? That's our new Big Mama formula. There it is. Okay, now we're going to the other 2 methods. One of them you already know, and one I told you to please save for later. So the one we already know is using factoring and the zero product property to solve 2a. So what times what makes negative 30 and adds up to 13? I hope you're thinking 10 and 3. Oh, does that work out? No, it does not. And so what else times what else equals 30? You got it. It needs to be 15 and 2. So is it 2 minus 15 or 15 minus 2? There you go. So we get x plus 15, x minus 2. Those 2 factors are equal to 0 so that we can use the zero product property. So if those 2 things are equal to 0, I know that either this factor or this factor are equal to 0 or both. So we set each one equal to 0 and solve. And then we add 2. And there's my 2 solutions. My 2 real roots or 2 real solutions. Save this guy for later. All right, the bottom one, 27 can be rewritten as a base of 3, 3 to the third, and 9 can be rewritten as a base of 3, 3 squared. But there's a little tiny 5x right here. Don't forget about that. So this becomes 3 to the third over 3 to the 10x. And my final simplified answer becomes 3 to the power of 3 minus 10x. It's asking us to simplify the expression and make sure that the answer is in exponential form with a single base. There it is with a single base. All right, how about 125 and 625? Pause the video, go look at your green sheet. How can those be rewritten? Okay, so 125 could be rewritten as 5 to the third. Good. Now look up the 625. Awesome. It becomes 5 to the fourth. And so we're rewriting this as a single base using, in this case, the add rule, this plus this. So we're going to write it as a single base 5, 3 plus 4x plus 4. If I distribute that, final answer is 5 to the 4x plus 7. See if you can follow along to all those steps. There it is rewritten as a single base.